Hello and welcome to another tutorial! In terms of showing the basic, most effective way of upscaling and denoising, I'm just going to go straight to the program of choice, which is Topaz Gigapixel. Never heard of this. Alright, let's use this great piece by Robin McCall by Visitation 1981. Let's go for a magnification that isn't too much. You know, you're not going to get an 8K sharp image out of something that's sub 1000 pixels wide image. So usually around 2x, 3x. And I'm going to select a value that's relatively high because there's a lot of noise. So let's just crank that up. You know, if there's less noise, I'd use a lower value. The auto switch? I don't know, I'm not casual, I'm not gonna forget about that. And that seems about it. Thank you for watching, and I'll catch you later. Wait a sec, what's going on with these rainbow colored halo effect going on here? I'm just gonna plug this into Wave2X, level 3 CONET model, and same scale magnification as I did with the Topaz Magnify thing. Let's go to Photoshop, overlay it over the Topaz result, and then set that Wave2X result as color, and crank that opacity down to 49%. Add a little bit of sharpening, as low as I've done here with the preset, even though this is essentially the best overall easiest method of upscaling. But does it really yield the best results 100% of the cases? Well, my sweet summer child. There's a lot to go through. So, come on in and let's go through this upscaling guide on how to make images, well, admittedly 10% better, or maybe more in some cases than this basic method. So come on in! Alright, sure it's been 5 years last time I made the tutorial, but hopefully I got the juices flowing.
Oi mates, GameXU here.
Bloody stupid.
And to compensate that, I've got a better mic. So this tutorial is mostly a combination of general overall tips when using Topaz Gigapixel and the stuff we'll do in Photoshop for most upscales when we want to combine layers and stuff like that. But then the rest of the video is basically me trying to encompass a bunch of scenarios and stuff between the main categories I've concised down to, and through my ventures, which are essentially either I'm dealing with photos, artwork, print scans, and illustrations that have their own denoising techniques. And in terms of the other Topaz packages such as Denoise AI and Sharpen AI, they're a whole different level of usage and what you can do with them. Sometimes they can be very simplistic in its usage, say like if you have a native res image that you take with like a DSLR that's like 15 megapixels and it's very grainy because of a high ISO you set when the night scene, and it can be very mitigated easily with that program with using some simple sliders and values. Although you can achieve near identical results with Topaz Gigapixel and some editing, but you got the advantage of obviously that you got the chance of upscaling those noisy scans in the process. And same goes with Sharpen AI, which is simplistic mostly because you just plug it in and you just set down the denoise value, say if you don't have much noise you want to compensate and you want high sharpen. But admittedly, from what I've tested, sometimes the combos you can do with importing first in Gigapixel then going to Sharpen AI, you can get some really good results. And when using those combos, say like Denoise AI, then Sharpen AI, or Gigapixel, then Sharpen AI, there's different ways to go about finding the best way to denoise your pictures. And what I've achieved with this is a whole different workflow in itself. And I'm not going to cover that because this is mostly just about Gigapixel only. Because say if you just bought Gigapixel only and you only have left for free software like Wave2X, which is our great other companion that you'll be seeing throughout this tutorial / guide. But if you don't want to buy Denoise AI and Sharpen AI, there's always the other type of method. But other than that, for most part, I'll be exploring scenery, illustrations, photos, and stuff that's generally not human photography and stuff that have like, say, from big figures or to humans that are just like ants on your pictures. Although you can apply 65% of the stuff that you've seen here for the cases. It's just about finding the right settings that won't destroy the realism of your photos and make them uncanny levels of ugliness in your cases if you don't pay attention to what you're adjusting and how much you're denoising. Oh yeah, these techniques are also tied with the software updating and stuff. Means that there could be some things that go outdated because there's some kind of new groundbreaking feature that just, makes it obsolete. But I have a smart suspicion that Topaz Gigapixel feels like we've kind of hit the ceiling in terms of what marvels and results you can get from this upscaling miracle. Especially when contrasted with the old techniques and software that I did before using Topaz Gigapixel, which you can see about here, this whole history and how I've essentially been doing this for a couple years now. Also, finally, is that there's going to be a Vimeo version in the description if the YouTube compression annoys you for this demonstration. Alright, let's jump in. Let's just grab this image and wait a sec. Let's just make sure that we reverse search and go through like say 10. Wait a sec, there's a smaller version? Hang on, this version seems less blurry than what we initially went with. And it just seems like someone just went to Photoshop and resized it using bicubic or Lanczos resizing. And yep, that's the first thing you want to pay attention. You always want the original version of the image that hasn't been altered in any other way between. Because essentially, think of it like you can't polish a turd. When it's been resized like that, you've essentially lost the original detail from the image. And that could be very vital for Topaz Gigapixel given how its AI can deduct sharp little pixels, say, instead of just smudges of pixels into some kind of object which you'll be seeing. Alright, let's get cracking in this program. Let's first go through the preferences though. Initially, I just basically make sure that the program is using discrete GPU because CPU, even though I never tested, it's going to yield much slower results. And graphics memory consumption is up to you. And you want to make sure you use maximum quality AI models because you don't really want to use low-res results, right? Anonymous data collection? Well, if you like using Facebook, I guess. So let's get right to the meat and grind of this thing. Let's first start with file format. Usually I don't convert file format, I just go with PNGs and JPEGs for the most part. But of course, if you're using TIFFs, then if you want to convert it, then there's your option. Although, say if you're worried about you doing a JPEG to a JPEG, you don't have to worry about the quality because they actually use maximum quality for JPEG. And I even went tests out that there was actually to make sure there's no compression by first initially converting that JPEG to a PNG, then putting Topaz Gigapixel. And from when I compared it, there was actually no difference between the JPEG version. So we can just stop worrying about that. In terms of scale, it's fairly straightforward in terms of what type of resolution you want to output, but usually I found myself constrained to 4x since I mostly upscale low-res sources. And there's only so much magic you can go from a source where if you say like you're going for 8x and expecting sharp results all the way down to 100% scale, it's gonna end up being messy, blurry blobs of just mess. And you may just want to go back and reverse search again, make sure you have the best source, and say that you actually do and you want to go beyond that, you can go ahead, but just expect the messy, blurry blobs thing. But say if you have a nice 1440p plus source or some high-res picture, you can go ahead and go crazy with that slider. Say if you want a really nice large print that's like 50 megapixels, because you have a bunch of information from the get-go in comparison to those poor little sources which have probably like sub 1000 pixels wide. In terms of performance and render times, the amount of width or height you enter is basically just a program just upscaling 2x, 3x, or 4x, then resizing that image down to that width or height that you enter. Since I guess upscaling programs work like that, and you'll get the same render time, say if you're going for 2.5x between 3x, it'll basically be the same as 3x. And this also applies for Waifu 2x. Now with the sliders, the remove blur for the first part doesn't do much unless you're upscaling image with a lot of motion blur. And I haven't tested out much because I've just left with the 0.5 for the most part. And it acts as a little sharpening thing. But the real deal is here. The suppress noise slider is pretty much this big bad boy that's going to determine whether your image is going to end up being very noisy still or something that has mitigated a bunch of noise in a very nice manner and left really nice line work. And if you're not aware, it's going to basically mitigate on an AI model of how much you want to mitigate that noise, whether it be noise screen, JPEG artifacts, blocking. And say for starters, let's say you have a very nice PNG and there's no JPEG artifacts to note of. You usually want to go around 0 to 0.5 for the suppressed noise value. Also, just as a quick tip, say if you're on the old versions, really old versions like Topaz Gigapixel 3, and instead of a 0 to 1 scaled, it would have a drop down menu going from lowest, medium, high, and you'd basically correspond, say 0 is lowest, 0.5 is medium, and 1 would be highest. On the other hand of this PNG that has no JPEG artifact, let's go to a example, our Visitation 1981 piece, which has a really messy JPEG artifacts, JPEG blocking everywhere. You don't even have to zoom in that much to see it. From there, I'd venture around 0.75 to 1 for this case. Now, a lot of images have case-to-case situation, and spending the extra 10 to 20 seconds comparing between 0.25 to 0.75 and so on would definitely better help finding the result you want. But if you're all about time constraints, wondering, light JPEG artifacts you see in like ArtStation or Twitter images, for example, you probably want to venture around 0.1 to 0.25, and for the most part should do it. And again, just to reiterate, very minimal artifacts, or just straight up PNG that are just clean, no JPEG artifacts, you go for 0 to 0.1 to preserve those textures. Also, I'm not sure about this auto button since I didn't find anything beneficial in comparison to just manually adjusting it and following the rules of thumbs as I just mentioned, but again, your mileage may vary. One tip I can give for venturing and finding the best result is to look for small specks in the artwork that aren't JPEG artifacts, say this little bit here, and are actually a part of the artwork you want to reserve. Then you just want to adjust the sliders so that the opacity and lightness of that speck match the source image. So here you can see I'm lowering the value, and the dot is still brighter and prevalent than the source image in comparison. So let's just keep on going on until it matches. And here it looks around good, and you can always look around other spots and make sure that Linework and bits are all good, if you're all happy-nilly with it. And this is all because denoising is all about mitigation and the extent of which you want the program to remove those tiny bits as artifacts. Although this can also account for small bits that you actually want to keep. And it's all about manually checking the denoising amount and ensuring you actually get the right result. Another thing you want to look out for, given the current state of Topaz Gigapixel and many versions I've encountered, are these gradients and solid colors being screwed up, especially on higher denoising values. And this is usually prevalent in images with large surfaces of gradient, where I guess Topaz can't decipher those gradients with smooth ones. So you want to make sure that you keep on checking and tinkering that slider, and you won't be getting this very ugly blob when especially going for the higher denoising values. So you want to keep a nice balance between denoising and finding a denoising amount that actually denoises a good amount, and you won't be going values that have negligible amount of denoising effects and will continue to distort those gradients, since they usually occur above values of 0.5. And note that sometimes even Waifu 2x color layer can't even fix this, so you have to manually adjust these spots in Photoshop, so keep the practice of balancing out the denoising value. Final thing, I just want to comment that from my experience, I found 0.5 to sometimes give relatively almost the same result as 1, since I'd say going from 0 to 0.5 is pretty much when the most denoising kicks in or something like that. And just think of it like a curve where 0.0 to 0.5 makes the biggest difference in denoising, and anything above that slowly crawls flat on the denoising curve. And this accounts for most images, but again it's a case-to-case thing. And say like with those special heavily compressed images, you can even find good results going from 0.5 to 1 and something that actually makes a difference. Now Topaz Gigapixel already showcased how it retains detail excellently while upscaling, but it's also a great anti-JPEGer in which even if the native resolution of the image is good enough, say like it's a 4K images, Topaz Gigapixel just takes the clarity to a step further, say the screenshot from Ready or Not. And even if you put the final result over the source image and the same resolution for apples comparison, you can already see the clarity and anti-JPEG going on, and just how much better it is without that JPEG crust. And this is great for even pieces like this by Ron Miller, where you can see the Starscape has quite the JPEG blocking going on, and going for a Topaz Gigapixel, you can see how the result gave this nice better pattern in the Starscapes. It's like it's moving it and remove the blocking in process. But what if Topaz Gigapixel result wasn't always the best, and you see some bits that are better in the result from Waifu 2x? Well, now we have to get into some manual work in Photoshop, and the idea of combining different renditions and basically making things either 10% better than the original just using Topaz Gigapixel, but it can go a long way in some scenarios, which you'll be seeing. Now let's go back to that color layer thing where we resolved that rainbow halo problem we saw earlier, and then we set that color layer to 49 opacity for some reason. Essentially, Topaz Gigapixels sometimes alter the colors from the originals to a set degree, given the case-to-case thing, and it's just individual for every image. Usually, if there's more artifacting, then the color alteration might become more prevalent. And it's also based on how high you set the denoising value, as exemplified by the altering gradient issue we saw, where large gradient and solid color surfaces suffer from this ugliness on high values. There's also the fact that the rainbow halo effect is also caused by large size artifacts left from Topaz struggling to denoise specifically nasty parts of the heavily JPEG images, say in this place that's quite ugly. With all these set issues and however long it will take for Topaz Gigapixel to update and solve this issue once and for all, I definitely recommend having a color layer to solve this in the first place. And since you are upscaling with a GPU, that usually takes around 10-ish seconds per image on average, and not like 10 minutes with a crappy Celeron, right? Given any NVIDIA GPU for the last 6 to 7 years can upscale waifu2x in around 6 seconds, and it shouldn't really be a problem. But if you're more of an AMED user like me, you can always use alternative waifu2x redistribution that uses OpenCL or even Vulkan instead of CUDA that the Cafe versions use and enforce, or else you have to use CPU, which can be quite slow. And the only upside that Cafe has is that it has the most update in terms of new models such as CUNet, which is a slightly better version than the oldish models from the alternative versions, up RGB in terms of edge retaining, which I'll be covering soon. But it shouldn't be a problem, really it's just a perfectionist thing. Now about that 49% best overall opacity, why not just 50% since it's easier to type out in Photoshop by just hitting the number 5 on your numpad on a selected layer? This may be an only thing in Photoshop for the situation, but for some reason 50% or above starts to introduce this very slight issue of banding and artifacting seeping through, most noticeably on large surface and gradients, which might be invisible on more complex to normal detailed spaces. But again, with this issue in mind, it's nice to safe on the safe side and reside to 49%. And this exact same result you can even see when exporting the image, so yeah. So why not 100%? Well, due to the way waifu2x you set level 3 as the strongest denoising value, you're pretty much denoising to a point where you're losing some of that colors from the thinner edges and shapes, since they're now matched up with this blurred up color thing. You can see from this example from this little triangle bit, where it's a stronger orange value has been drowned out from this blur. So pretty much having that color layer at a lower opacity allows to retain some of that color that Topaz Gigapixel better reserves, whilst dampening the rainbow halo effects, which is why I go for that middle ground. Let's go over the method of combining best of both worlds, demonstrated with this light streaks upon sunset piece. Essentially it's all about overlaying the different versions of bits and seeing, say like this waifu2x version where we want some of the bits between the squares and the lines from the streaks. So we just erase it from there. And sure, it may be 10% better looking, but if you want the best, then by God. You may also want to consider turning down the opacity of the erase tool by 50%. Say you want a little bit of Topaz Gigapixel and waifu2x results. Since having just the waifu2x result at 100% of its bit, it might be too unsharp in comparison to the Topaz Gigapixel results. This can get extensive with cases like the ComTrue's diluted and ZipZap pieces here, examples. And you have just all these bits all over the place that needs attention, and you have to find out where you want to erase the bits with varying opacity, such as with these lines, and controlling the hardness of the eraser. Say for gradient bits, you want to keep a lower hardness so it transitions much better between the Topaz Gigapixel result and the waifu2x result, and boarding between bits that you want to make sure is hardened between the Topaz Gigapixel and waifu2x results with a hardness eraser. Wait a minute. Let's just change that. Yeah, that's better. Strong hardness eraser. Some more extreme cases of using waifu2x, say this screenshot from Stranger Things 3 with the Starcourt Mall. And sometimes I still have to use waifu2x for these really crusty parts, say like these lines, and just overall blending bits that just end up being better from waifu2x. And even with the highest denoising in Topaz Gigapixel, you still have to basically find bits that Topaz Gigapixel doesn't do as good as waifu2x, say with the lines as I mentioned. There's even cases like this where I have to turn the color layer to 100% opacity. It just ends up being that the color differentiation and alteration from Topaz Gigapixel was just too severe. Again, it's all about mileage and finding out if the crustiness is just too much. Now say if you have these messy, ugly gradients and solid colors that might be a glow from the neon or a sky from a photo, and you want to fix this with something that will basically smudge in it, and that's where Gaussian blur comes in. So I just duplicate a layer and then have the Gaussian blur layer underneath and erase the bits around so I can retain the neon bits. In order to make sure that I retain the neon bits and not have these small pieces where they're just Gaussian blur neon, you can use color range select to fetch off the neon streaks and basically erase away and make sure to stay within the range between what's the Gaussian blur sky or glowy parts here and not the objects that are fine streaks or lines. Now what if you have all these banding artifacts starting to showcase? Well, you can start to use the splatter technique, which is basically this type of technique that compensates the 8-bit limitation, as opposed to using 16-bit mode, since that would basically bump up the file size quite dramatically. And in order to compensate that, you duplicate the layer, use Gaussian blur once again, then go to filter gallery, select splatter, and then use smoothness 1, and then just adjust the spray radius value from there, where you want to stay high enough that you compensate the banding effect, but you don't want to go way too high where the splatter is bleaking in all over the place. Now due to the video compression, which is then followed by YouTube's compression, the demonstration might not be accurate, but if you do it yourself, you'll see the results quite staggering. You also want to stay away from objects when erasing the bits that you want the splatter layer showing off and what's from the original. It's all about making sure that you don't have this splatter bleaking in way too much. Maybe have a little bit, but not too much. I mean, goddamn, look at this background where it was initially just a very ugly banding, artifacting, all this stuff all over the place, and then having to use Gaussian blur, splatter, and you have this very convincing, smooth background. So let's get into the concept of combining different line works from different results. So let's say you like the line work from the Waifu 2x result, level 3 in this case, but you want the detail from the Topaz Gigapixel result. So in this case, we just want to duplicate the Waifu 2x layer. As for that top layer, we'll be using filter, stylize, find edges, or whatever other ways you just find edges in other programs. And from there, you want to make sure you first select white for the color range. Then turn up fuzziness 200, as that will be able to make sure that you select everything that is not line work, because if you put anything lower, it will start to select stuff that's more of the artifacting, say. So from there, we just want to select mask and then turn up the edges so that make sure that the line work reaches to the part where you can start to see the artifacting around the line work from the Topaz Gigapixel result. So we just use a combination of feather and shift edge, probably like negative around 60%, not 100, as that will start to select the middle bits that's not line work. You'll see for yourself if you go, test out yourself. But from there, we just then select it, then select inverse once we're done, and duplicate that layer once more because the feathering would have the initial layer as semi-transparent. And just to make sure that line work layer is fully opaque, you can just hold Alt and left click on the eye icon, and that will make sure that you isolate it from the other groups, and then you can see, well, yeah, it's opaque. Now let's say we're dealing with more detailed photos and artwork where you want to retain that grainy noise, say in this case, but you like the line work from the highest denoised version. So we went from 0 for the detailed grainy noise and 1 for the line work. Since this is the case where the original image was a really nice PNG or some JPEG but has minimal to no compression. So in the case we want to retain that texture or noise from the 0 denoised and the highest denoised version, but you want to keep the line work. So in this case, you want to make sure that we actually do the find edges filter thing to the Waifu 2x result, because how Waifu 2x has least amount of artifacting from the in-betweens and anything that isn't the line work. From there, we just do the same process where we grow the mask and make sure that it reaches just enough for the line work where it stops, and to make sure that it doesn't go far beyond to affecting the grainy noise texture we want from the in-betweens. And once we have both, you do the same, select inverse, duplicate the one full max result, and now we have the best of both worlds. We have good line work from the max result, it's more sharpened, and we have the original grainy texture look from the least denoise version. Now let's get into the concept of print scans and old photography that might be blurry, and they may seem good enough to upscale, say like their 2000p, 5K, or even high enough resolutions. But when you plug it into Topaz Gigapixel, even at the highest denoise level of one, there just seems to be these noise and blur that doesn't seem to be mitigated as good enough as they can, even with the highest denoise. And those blurry spots and just like the detail is just not sharp enough. So what do we do about it is we do the concept of having to downscale a couple steps down, say from 2000p down to 1200p, to allow these pesky print noise or the blurry edges to decrease to a couple pixels down so that Topaz Gigapixel can kick in its AI power of having to decipher these just couple pixels as line work. And you'll definitely see what I mean when you recall back to the first point where I mentioned how you want a good source image that wasn't just resized lazily by cubic means, because having just given Gigapixel something where the edges are just blurry is just something that it cannot decipher as good as, say, a source image that has those edges as even like a couple pixels. It'll decipher as a line. This goes the same for print noise, because once you use downscaling, you're just taking these print noise that are just a couple pixels before into obscurity, and they're just pretty much nothing. So with that, Gigapixel can just decipher those little dots that were just once these really sharp print noise that you don't want as nothing, and then it'll denoise and take it away magically. I pretty much learned this the hard way with having this extreme example, Night Illumination Grand Court, where the picture was beyond blurry, and I pretty much looked for ways to mitigate the blurriness and turning them into something that's actually comprehensible edges and sharp ones at that. So in the end, I found that I had to downscale all the way from the original 7121x5359 down to 1440x1084. And note, this is from a Wikimedia archive, so they usually have the highest resolution photography and art when it comes to stuff like that. So obviously the levels of which you have to downscale and then upscale is a case-to-case thing. So how do we figure out what resolution will play best? Well, for me, I just make a folder and then downscale the scan down in increments and save those increments as PNGs. So I'll try out 2338p, that's the original, 2000p, 1750p, 1500p, and so on. Although at around 1000p and below, I slowed down the increments by 100p steps, since say from going from 700p to 800p can make a big difference in the results compared to 1500p and 1750p, where you might find that Topaz Gigapixels can still not compensate those blurry edges as something that's for something sharp. So once you got those increments you want to try out, just plop them in Topaz Gigapixel and crank up the denoise to 1. In this case, since without a shadow of doubt, we just want the best results when it comes to mitigation, and make sure that we want to denoise as much as possible with these ugly print dots that's from the original. If you want to retain some of the textures, say from the better looking scan, you find one to be too much, then there's some considerations you can take. Also, to make comparing results much easier, I'd set the width to 384 so we have a nice 4K scan, and it's easily, you can say it's a 4K scan instead of having different resolutions when you're comparing. You can also compare quickly in Topaz Gigapixel preview window for relatively decisive results. Say the high-res versions have no hope compared to the low-res results, so we can quickly remove those before having to bulk denoise a bunch of images. Although note, these results might not be reflective of the actual final results once you've denoised them, so keep that in mind when making the absolute final decision with the results, since you not want to compare it in a preview that might not be 100% to the actual results. Alright, so once we got the results, I'm just going to plop them in Firefox like this, and now we have all the images loaded incrementally. Also, I use Firefox because for some reason Chrome has this issue where if I tab switch, it is like a flash blank thing that happens, unlike Firefox where it just switches one to another without having this flash, because I don't like epileptic seizures. Also, if you're not seeing any noticeable differences between each, you can do this thing where you can keep the mouse still, then zoom into one place. So say let's hover our mouse right around here, then just tab switch and keep on clicking in that spot without moving the mouse. And now we can keep the zoom right there, tab switch, and then compare. Alright, now we got our decided result. We're just going to take that downscaled resolution to Waifu 2x and magnify it enough for the final results. So say like it's 1000p and we did 384 for the Topaz Gigapixel result. We just want to do 4x, and for that we're just going to plop it in Photoshop as a color layer, and that's pretty much it. There might be cases where you might have to take stuff a bit further, say with the Scan American Cinematographer Star Wars 1977, where I found the best overall looking result from the downscale to 1000 by 1396. But when comparing the results, I found bits like the stars here, the noise bits here, and edges better from the 1400 x 1955 downscale. So I combined the best of both via the erasing bits technique, and then keep the better overall 1000x1396 result on top to keep the texture in place for all the other parts. And again, it's all about testing, comparing, and if you want to take the leaps to find which results gives the best place in one or another. Say a lower res downscaled one has better results of a more particular noisy part of the picture that a higher res downscaled one cannot compensate as good as the lower res one. Here's another example of a piece you may or may not know based on its original context, which is Michael Stern's A Journey in the Key of Space cover pic. And you can see how I differentiate between the original result that I found the best, which is a 700p result, as the base layer. Although there are some bits that I liked from the 1200p result. And you can see how I differentiated. Seeing these star bits that I liked from the 1200p result were sharper. And from initially, just before I'm going to crank it down a couple of steps, you can see how initially the 1200 result had these print noises that weren't resolved and mitigated, so I had to erase them in order for the 700p result to showcase the better result. There were some cases where I decided to keep the suppressed noise value lower than just going full crank at 1. And at first I did like the initial result, although seeing after a while I started to notice the noise a bit too prominent. So what I do just for a quick fix, instead of going all the way back into Topaz Gigapixel, is just bring it to Waifu 2x and denoise with level 3. From there I'm like, alright, this is pretty good. But there's some bits that are still too noisy, so say like this, where the purple sky on the top right is, and what I just do is duplicate that and then use some quick type of effects such as surface blur in order to mitigate those noises a bit more. Now I wouldn't rely on surface blur for the denoising from initially, because Waifu 2x is just the best overall still in denoising because it retains the line work much better than surface blur. So keep that in mind, just use surface blur just to a little degree. Oh yeah, and just for something completely out of field to make things even more complicated, sometimes the native resolution of a noisy scan can actually end up being the best for denoising. How about that? Now for simpler illustrations, there are two levels I like to call it. The first was a combination of mostly strong focus on line work, and there are some noise and details you want to retain. And the second one is pretty much only about line work. Now let's start off with the first level, which is simply where you can rely on Gigapixel for the most part. And we can go to high suppressed noise values of 0.5 to 1, because the higher values start to mitigate the line work. As we saw before, they were mitigated more extensively in turn for the denoising to sharpen the edges. And we can rest easy about the fact about the final details because, for example, in this piece titled X-Wing, there's not a lot of fine details that's outside the line work. And as you can see, I'm talking about that prominent line work and a little bit of the noise and details that Gigapixel can do a good balance between. And let's say you're still not satisfied about the line work from the Topaz Gigapixel result and you like it from the Waifu 2x result, you can always go back to that technique where we combine the Waifu 2x line work with the Gigapixel, and from there it's all happy and doing. Now for that second level of illustrations, which is pretty much now this reliance on this high level of denoising for Gigapixel, so I stick with 1 or probably a little bit like 0.75, but nothing lower than that. You then additionally want to go back to Wave2X and then bring the Topaz Gigapixel result to Wave2X with level 3 denoising, since Gigapixel would probably leave these artifacting around the line work that you don't want. And since we have this much emphasis on line work in this case, that's where Wave2X shines compared to weaker methods like Photoshop's surface blur, which is okay but not as great as Wave2X. You can go further with cleaning up stuff, say if your image still has artifacting and these unwanted blurry stuff around the edges. You can use stuff like color range to select a certain color that's plainly just something like white in this case, and you want that white as white and not mixed with these smudges of gray. So you can select color range and then adjust the fuzziness to your likings and then duplicate that and then use blending options, color overlay, so then you can have the white as white without those ugly smudges that you don't want. You can even extend this to artwork with a simple amount of distinguishable colors, say just like 5 clear solid colors in this piece, and then you can use color range to select those certain colors and then use color overlay. Then I'd go back and check between little details, say these small like sliver of lines where they're stopping, and there might be cases where the selection mask was too strong in those small certain crevices that you want to retain. So you can erase those bits, and then probably if you want to go the fast way, you can also shrink the mask overall to better preserve some of the edges and crevices, but you don't want to go too far where you start to bring back the artifacting and ugly smudges and glow that was initially there. And then it's all about balancing between that and the manual work you have to do in some places, because the crevices would be, you cannot just do it without full auto color range. Now, a final word of advice with these illustrations is that when it comes to sharpening, we've usually gone with slowest sharpening or stronger with photos and detailed artworks, since they sometimes end up being like a few of dithering pixels that make the images, and nothing that have distinguished line work and stuff that's just solid color, although this is the case with illustration. So when it comes to sharpening, you can clearly see this side effect of having this 1 pixel wide white line that's occurring. And it would be much more visible with these simple illustrations that have line work and then just solid colors in comparison to photos that have all this noise that can hide that sharpening. So even if it's the case where it's just using even the lowest sharpening amount and it's still see that white side effect line thing, then I'd rather just not do sharpening at all. And that's pretty much it for Topaz Gigapixel actually. Just as promised, when I go a little trip back into what I did before Topaz Gigapixel, I initially started this like 4 to 5 years ago with Wave2X, where I actually did the same technique where I'd use the edge work from a higher level of denoising, so level 2 would probably give better line work, and level 1 would better keep those details and noise intact. And I still do the erasing bit technique where I want to erase from bits here and there and have the best of both worlds between different renditions and results. And it's all about that art of perfecting and comparing results and finding which bits you like better than the other. So say this piece, this A12 parked picture that demonstrate where I found bits from level 1 keeping the windows and tarmac better, then level 2 where the solids in the sky were better. And then compared to Topaz Gigapixel, yeah, it pretty much destroys it in every aspect. And even actually before I used Topaz Gigapixel, I used something called Let's Enhance.io, which was a subscription-based service. And it's obviously not as value incentive as Topaz Gigapixel, which is just you buy for $100 and that's it. Now, Let's Enhance.io was actually very spotty and it lost a lot of sharpness when I used it back in 2018 around-ish. So maybe the model got better, but I didn't try again really. Maybe the texture problem is still there where it just overlays this grainy thing all over the picture, and it's not as good as Topaz Gigapixel obviously. There's also that level of just finding these type of software in just random comment threads, like for example I found Let's Enhance.io randomly in some comment thread, and that was an eye-opener. Then I found Topaz Gigapixel, and that was another eye-opener pretty much in another whole level. There's also this other level of having to be involved in the community of just AI upscaling, like for example knowing the in-how of just say like this ESRGN. That's another good free thing you can try out, although I haven't tried on myself much because I don't know how to properly use Python and installing the redistributors and everything and just typing out code really to that level of degree. So you can try it yourself, and just knowing about this type of whatever's the new hot AI model is pretty much a whole art in itself. Although you can also just use Gigapixel because the the way they're updating is pretty good. And I have to say, being a proud user of Topaz Gigapixel around late February 2019, I'd say it's pretty much the top dog. Well, that's about it for me. So, if somehow you didn't catch anything I said for some reason while watching this, you can follow the full kind of script in the video description, which say it has most of the stuff. I mean, you can always use YouTube's auto captions, which is pretty neato and accurate, but it's there because... Oh yeah, also make sure to support me on Ko-fi.
Hey, does anybody want coffee? Who wants coffee? I just made a fresh pot of coffee. Does anybody want coffee? Buddy, do you want coffee? I need that, man. I need that. Do you want coffee? I just made coffee.
I actually didn't even consider some kind of pool for donations when making this video, but I literally made this page just when I thought of that clip, so here's to that. I really don't have anything to offer for donations in terms of goals and stuff. It's just there, so thanks. Also, I urge anyone with any confusion, questions, do leave them in the comments, because I'm quite certain that the stuff I cover can be quite daunting, and most of the stuff is just a matter of practicing, understanding the techniques needed for what picture, and just being one with J-Perk.